Last time, we took a detour to know a little about the history of astronomy. Navigating back to the main timeline, this time we'll be taking a closer look at the solar system and the heliosphere. We, as humans, are inquisitive by nature, and one of the first questions we ask ourselves is where do we stand in the universe and what's our home? This question has puzzled scientists and philosophers alike for generations. So today, we have picked this topic for a much needed decluttering. We Earthlings are part of a small family in the universe called our solar system. The solar system is made up of all the planets that orbit our sun. In addition to the planets, the solar system also consists of moons, comets, asteroids, minor planets, dust, and gas. The big daddy of our family is the Sun, which contains around 98% of all the material in the solar system and keeps each progeny of the solar system in check through its large and powerful gravitational force. Balanced between flying towards the Sun and escaping into space, they spend an eternity orbiting around their parent star. Can you assume what's the size of our solar system? Take 5 seconds to guess. Of course, in the end we'll give you an estimate, but that shouldn't stop you from taking a guess. Our solar family extends much farther than the 8 planets that orbit the Sun. The solar system also includes the Kuiper belt that lies past Neptune's orbit. This is a sparsely occupied ring of icy bodies, almost all smaller than the most popular Kuiper belt object, the dwarf planet Pluto. There's also the Oort cloud. This giant spherical shell surrounds our solar system. It has never been directly observed, but its existence is predicted based on mathematical models and observations of comets that likely originate here. The Oort cloud is made of icy pieces of space debris. The size of each debris is comparable to the size of mountains and sometimes larger, orbiting our Sun as far as 1.6 light years away. This shell of material is thick, extending from 5,000 astronomical units to 1 lakh astronomical units. For reference, 1 astronomical unit is the distance from the Sun to Earth, or about 93 million miles. The Oort cloud is the boundary of the Sun's gravitational influence, where orbiting objects can turn around and return closer to our Sun. Can you even imagine 1 lakh times the distance between the Earth and the Sun? Mind-boggling, isn't it? So how did it form? Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar gas and dust. The cloud collapsed, possibly due to the shock wave of a nearby exploding star called a supernova. When this dust cloud collapsed, it formed a solar nebula, a spinning, swirling disk of material. As the center of gravity pulled more and more material in, eventually the pressure in the core was so great that hydrogen atoms began to combine and form helium, releasing a tremendous amount of energy. With that, our Sun was born, and it eventually amassed more than 99% of the available matter. We have already talked about this process in a previous video. If you missed that video, you can check that one out. Ever imagine what the solar system looks like? What's the shape? While matter in the central region was doing its thing, the matter farther out in the disk was also clumping together. These clumps smashed into one another, forming larger and larger objects. Some of them grew big enough for the gravity to shape them into spheres, becoming planets, dwarf planets, and large moons. In other cases, planets did not form. The asteroid belt is made of bits and pieces of the early solar system that could never quite come together into a planet. Other smaller leftover pieces became asteroids, comets, meteoroids, and small irregular moons. The order and arrangement of the planets and other bodies in our solar system is due to the way the solar system formed. Nearest to the Sun, only rocky material could withstand the heat when the solar system was young. For this reason, the first four planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They are small with solid rocky surfaces. Meanwhile, materials we are used to seeing as ice, liquid, or gas settled in the outer regions of the young solar system. Gravity pulled these materials together, and that is where we find gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. When we talk about the solar system, there's one word that gets closely associated with it. It's the heliosphere. Any idea what that is? Again, you can take 5 seconds to think about it.
There are a lot of 5 seconds breaks going on. Maybe he needs a break. Come on, he's a human after all.
So, did you think about it? We won't keep you adrift. Let us give you the answer. The heliosphere is the magnetosphere, astrosphere, and outermost atmospheric layer of the Sun. It takes the shape of a vast, bubble-like region of space. In plasma physics term, it is the cavity formed by the Sun in the surrounding interstellar medium. It is the region of space encompassing the solar system where the solar wind has a significant influence. The Sun sends out a constant flow of charged particles called the solar wind, which ultimately travels past all the planets to some 3 times the distance of Pluto before being impeded by the interstellar medium. This forms a giant bubble around the Sun and its planets known as the heliosphere. It is important to study about the heliosphere to better understand the fundamental physics of the space surrounding us, which in turn provides information regarding space throughout the rest of the universe as well as regarding what makes planets habitable. The solar wind is a gas of charged particles known as plasma, a state of matter governed by its own set of physical laws, just as the more common solids, liquids, and gases are. As the solar wind sweeps out into space, it creates a space environment filled with radiation as well as magnetic fields that trail all the way back to the Sun. This space environment is augmented by interstellar cosmic rays and occasional concentrated clouds of solar material that burst off the Sun, known as the coronal mass ejections.
Oof, that's a lot of information. Pause the video, take a moment and process it, or maybe replay it to get complete information and only then go forward.
This complex environment surrounds the planets and ultimately has a crucial effect on the formation, evolution, and destiny of planetary systems. For one thing, our heliosphere acts as a giant shield, protecting the planets from galactic cosmic radiation. Earth is additionally shielded by its own magnetic field, the magnetosphere, which protects us not only from the solar and cosmic particle radiation but also from erosion of the atmosphere by the solar wind. Planets without a shielding magnetic effect, such as Mars and Venus, are exposed to such processes and have evolved differently. The Sun's heliosphere does not extend throughout the entire solar system. The boundary, where the solar wind is abruptly slowed by the pressure from interstellar gases, is called the termination shock. The edge occurs between 80 to 100 astronomical units. That's where our heliosphere ends.
I say that's where we should end for today. There's a lot of information for curious minds to grasp. Let's continue with the rest next time, shall we? Stay tuned, as next time we'll be talking about the effects of these bodies in our solar system and on our planet, especially the effects of two particular bodies. Until then, keep exploring.